Has organic chemistry been troubling you, wondering what it's all about, or it's been so difficult for you? Today I'll be breaking it down step by step in a revision section. Now, first of all, let me take you through the history of organic chemistry where you will learn better. In the 1800s, organic chemistry was seen as the study of the chemistry of living organisms. That is, compounds that come from plants and animals. And they refer to that as what? The vital force theory. The vital force theory. In 1827-28, a German scientist, Friedrich Wöhler, was able to synthesize urea, a compound in urine of human, was able to synthesize that compound from an inorganic compound called nitric silate. Nitric silate. And from this compound, he was able to heat it to dryness and was able to synthesize urea, an organic compound synthesized from an inorganic compound. This is the formula for nitric silate. It's an inorganic compound. If you heat it to dryness, it will form urea. This is the formula for urea. This is urea, an inorganic compound. So with this, scientists knew that the vital force theory has no chemical base. So they came up with a new definition for organic compound. What is organic chemistry? The modern definition says organic chemistry simply is the study of carbon and some of its compound. Carbon compounds. For example, the study of carbon and its compound. Elements like hydrogen, sulfur, oxygen, nitrogen associated with carbon in some compounds are also termed as what? Organic chemistry, organic compounds. There are so many organic compounds in nature. And why are there many organic compounds in nature? It's because carbon has a particular property. And that property is what? The ability to catenate. The ability to catenate. What is catenation? Catenation, simply put, is the ability of carbon atom to link up together to form long chains or branch chains. That is what catenation is all about. And carbon is able to do that. For example, I have a 5 carbon compound like this. 1, 2, 3, 4, 5. They can link up like this and form a compound we call pentane if all the saturating atoms are hydrogen. If all the saturating atoms are hydrogen, we'll call it. Don't worry, we'll be coming to all this. You know how to write names of compound with ease. And they can also choose to link up in another 1, 2, 3, 4, 5. This thing, a 5 carbon compound, just 5 carbon being arranged in 2 different ways, and so on and so forth. And there are compounds, over millions of organic compounds, because of this ability of what? Carbon to what? Catenate. There are other properties of carbon. It has a covalent nature, it is flammable, and so on and so forth. This is not what I want us to look at in this class. Now, I want us to study something that will be able to handle organic chemistry with ease. First of all, let's study the concept of the alkyl. Alright. An alkyl group is a group derived from what? Losing a hydrogen atom from the corresponding alkane. So alkyl groups simply are groups that have lost one hydrogen atom from the corresponding alkane. Here we have methane. Formula is CH4. When you lose one hydrogen atom, we'll call you methyl. That is now an alkyl group. If you remove one hydrogen from here, you're going to have CH3. So this is methyl because it has lost one hydrogen from here. So you replace the ANE here with what? YL. That is an alkyl group. Now, ethane, C2H6. If you lose one hydrogen, it will become C2H5. And you call that, instead of ethane, you call it ethyl. Now let's look at propane. The alkyl group derived from propane. When it loses one hydrogen, propane is C3H8. Alkyl group is there. Give me the name of the alkyl group for propane when it loses one hydrogen to become C2H7. What will be the name of the alkyl group? Leave the answer in the comment section. Is that okay? Alright, let's look at another concept, the homologous series. Okay, before the homologous series, we need to look at a concept called the functional group. A functional group is an atom or group of atoms that determine the characteristics of a homologous series or a given family of organic compound. An atom or group of atoms that determine the characteristics of a given organic compound is what we refer to as what? A functional group. Now, we have so many functional groups. For each of the families, there are functional groups associated with them. For example, the haloalkanes, the functional group is the presence of what? X, which is a halide. For the alkanols, the functional group is OH. For the alkanoic acid or carboxylic acids, the functional group is COOH. For ethers, the functional group is ROR. For alkanas, the functional group is what? CHO. Alkanones, the functional group is C double bonded O. Then we have the primary amines. The functional group is RNH2. That's the functional group. Then we have our amides. The functional group is R triple bond N, and so on and so forth. Now, each of these functional group determines the properties of these groups. So when you have a halide here, it is this halide atom that will determine the property of this group. OH will determine the property of this group. COH determine the properties of alkanoic acid, and so on and so forth. So if you have been wondering what a functional group is, simply a functional group is an atom or group of atoms that determines the properties or the chemical properties of a given homologous series or of a given organic compound. Now, why alkyl group determine the physical properties of a given organic compound, the functional group determines the chemical properties of that compound. Are you following me? If you find this interesting, before we continue, why not give me a follow? If you have any questions already, you can leave it in the comment section while we continue to what? The homologous series. The homologous series. Please follow this carefully. The homologous series simply is what? A family of organic compounds that follows a regular structural formula in which each successive member differs by a CH2 group. That's what a homologous series is. Now, key things you must follow. They are a family of organic compounds that follows a regular structural formula. They follow a formula in which each successive member differs by what? A CH2 group. Now, I just wrote out the functional group of different homologous series. So, from your alkanes to alkenes to alkynes to alkanas to alkanos to alkanos to amines and so on and so forth that I just wrote out about the alkyl group. They are all homologous series. These are families of organic compounds. I don't need to write them out again because we want to study something else. They are all families of organic compounds. Call them alkanes, alkenes, alkynes, alkanos. All these are families of organic compounds and so on and so forth. Now, they follow a regular structural formula. That's what it says. Follows a regular structural formula, and each successive member differs by a CH2 group. For instance, the alkanes follow the formula CN H2N plus 2. The alkenes follows the formula CN H2N. The alkynes follow the formula CN H2N minus 2. The alkanos follows the formula CN H2N plus 1 OH. Each of them follows a regular formula. Now let's see how they differ by a CH2 group. Now I have a mnemonic for writing my first 10 alkanes. The first 10 alkanes, there is a mnemonic for it. Now I have methane, ethane, propane, butane, hectane, hexane. This is the first member of the alkane series. It has one carbon atom. Second member, 2 carbon atom. Third member, 3 carbon atom. Fourth member, 4 carbon atom. Fifth member, the fifth member is 5 carbon atom. 6 carbon atom. Then we have heptane with 7 carbon atom. Octane with 8 carbon atom. Nonane with 9 carbon atom, and then decane with 10 carbon atom. Are you following me? Now let's write the formula for each of this series. Now they say they follow the regular formula CnH2n plus 1. Now if I put 1 here now, I'm going to have C. Put 1 here because N9 is 1. Carbon, number of carbon equals to 1. 1 here now is going to be 2 times 1 is 2 plus 2, 4. That is how the formula for methane becomes CH4. Are you following me? Now let's do for ethane with 2 carbon. If I put 2 here, I'll have C2. 2 times 2, 4 plus 2. You have H6. Let's do for propane. C3. 3 times 2, 6 plus 2. H8. Let's do for butane. C4. 4 times 2, 8 plus 2. You have H10. Pentane. Carbon is equals to 5. That is C5. 5 times 2, 10 plus 2. You have H12. Hexane. 6, 6. So we're going to have 6, 6. H. 6 times 2, 12 plus 2. H14. Now, I'm going to stop here. We want to use the formula that say follows each successive member differs by what? A CH2 group. That means, let's confirm that first. What's the difference in carbon between C2 and C5? It's 1C. 6 hydrogen and 4. So each successive member differs by a CH2 group. Okay, let's do the second one. 3 minus 2, left with 1 carbon. 8 minus 6, 2. Okay, let's do for the next one. 4 minus 3, 10 minus 8, 2. So you see each successive member differs by CH2. So I don't need to follow this formula all the time or cram anything. I just need to know that if I have CH4, the next carbon I'll add CH2 to it. That is C here. C plus this becomes CH2. H2 plus H4. H6. C plus 1C plus C2. C3. H6 plus H2. You have what? H8. So I can now write the formula for this compound. C6 plus 1 carbon. I'll have what? C7. C7 plus 2 hydrogen. I have H16. Alright. H7 plus 1 carbon. I have C8. C8 plus 2 hydrogen. 16 plus 2 hydrogen. I have 18. This plus 1 carbon. I have C9. C9 plus 2 hydrogen. H18 plus 2 hydrogen. I have what? H20. The last one. You know, we are not adding CH2 because they say each successive member differs by CH2. Now, if I add this CH2, I'm going to have C add to this, become C10. C10 plus 2 hydrogen. C20 plus 2 hydrogen, you have what? H22. And that becomes the formula of the first 10 alkenes. Also, we can write out the formula for the first 10 alkenes, alkynes, alkanols, and so on and so forth. We'll look at them in the next class. In the next class, I'm going to take you into the concept of formulas of organic compounds before we start learning how to name organic compounds. If it's the first time on this page, do not forget to follow. Find this interesting, give us a like, comment, share, and don't forget to come back for the next episode on organic chemistry. It's going to be an interesting class. Welcome.